Good afternoon to all of you. I thought I was supposed to be the moderator, so I didn't prepare any presentation. So that's good. Taking cue from my friend Dr. Sonde, I was reminded of that film, Sound of Music. I don't know how many of you remember, this Uncle Fred used to ask the children to fall in line. And the last one, this little one, Uncle Fred, why I am always the last? And Uncle said, because you are the most important one. Oh, and that's it. The technology, how do you look at it? Because you are the most important one. I will just share with you on this subject of waste heat, 3 experiences of my career, rather than make a speech or a presentation. The first was I went to Japan in 1980 for training on energy management. And what struck me most fascinating, that post-73 oil shock, Japan decided as a nation, they were importing at that point of time 279 million tons of oil. Japan doesn't have any natural resources, energy resources. They were importing 279 million tons of oil to sustain their economy. The Japan as a nation decided they will cut down to 275 and still maintain economic growth at 7 to 8%. That was a target which the nation set. And the technologists, the policymakers, the regulators, they got together. I went for my training in 80, and I saw that graph between 1975 and 1979. 275, 278, 276, 279, and economy grew at 12%. And what happened? And one of the biggest thing was this energy efficiency. And on that, waste heat. And that was the first time in the world where they found the technologists, the regulators, and policymakers, unless they come together, you can't bring technology's benefit to the market. And if you go through the journey of technology to the market, you'll find this journey could not be short-circuited by any nation. And that's why it is very important, what my lesson was, that the policymakers, the regulators, the technologists, we cannot work cross-purpose. And I think the point Mr. Goel made in the morning, how do you convert stakeholders to the shareholders? I think that Japan demonstrated how you can do it. My second experience was, we were designing a project. The power system efficiency we talk of, it started 7-8% or 4-5% with the steam engine, 50-60% on combined cycle. So we started talking of how can we upgrade it. And we were designing a project that we target 80% efficiency. And in that connection, I went to Germany and had the chance to visit one center, energy center, they called it, outskirts of Frankfurt, and I saw a power system which was operating at more than 100% efficiency. Now, technically you can say it's crazy, but it was not crazy, because efficiency, when we define, we call it on NCV, the lower calorific value of fuel, because the moisture of fuel, which will go as an evaporation through the chimney, in any case it's a loss.
What was that project, Dr. Roy, in Germany, which you said 100% efficient?
That's a quadra generation project. I'm explaining it. Now, what they did, you have this combined cycle is called the cogeneration, and then you go to the trigeneration, where you have the power, the cooling, the heating. That's a trigeneration. And what they did over it, the vapor which was going through the chimney, the city heating condensate, return condensate, they were scrubbing the chimney with that and recovering the latent heat. So if you see the gas fuel, CH4, H4 hydrogen is the main fuel, but a lot of it is also going as an evaporation as H2O. So they were using the return condensate for recovering that heat. So they were getting on NCV over 100% efficiency. And that threw me, that put me into an idea that how do you really design a project which we call the minimum energy design? Now, when you say minimum energy design, it has many interpretations. For example, when you walk in a hotel from one place to another place, you can do a work study and say what is the minimum energy need to do it. And I read a book called The Natural Capitalism, which was a very striking book, where they demonstrated that our transportation efficiency is about 1%. And how? It's simple. If you're driving a car, the power efficiency is 30% because that's the heat to power. And then if you see that power you are generating, 900 kg to 1 ton is the vehicle which is being moved. And your weight, if me, it is 50, but if somebody else, it may be 80. So even then, it is half to 1%. So moving that 50 to 100 kg mass is what is the efficiency, because your efficiency is you are going from place A to place B. And so when I started looking at this, I said, why can't we use this concept for industry? And I had the opportunity to work in sugar plant at that point of time. And the sugar plant used to say, the 50% steam consumption, which means for processing of 1 ton of cane, you require 500 kg of steam, and that was the golden rule. I started working that what would be a minimum energy design. And so started working all these waste heat and everything, that you use all of it. And my model threw out 180 kg. So I made a presentation in an international conference in Brazil that I didn't say 180, I said 210 because I put some margin of error. And I was the only non-sugar person in that conference, and I was almost booed out that you are talking crazy. I said, yes, I might be. Look, I have done not from a sugar knowledge, but from a minimum energy knowledge. And I had the chance to work later on as a consultant to work with a sugar plant. And we started developing a platform. That sugar plant is today running at 330 kg. And when we were working on that, then came another concept that, this sugar cane payment is a perpetual political issue in the country. Then we said, look, let's see sugar cane, not sugar. What are the values we can generate per ton of cane? And being an energy man, I said, okay, let's first say the kilowatt hour. And at that point of time, the figure was that if somebody is exporting 30 kilowatt hour per ton of cane, it's a very good factory. Again, we applied the minimum energy model, and according to that knowledge at that time, it came to 80 kilowatt hour per ton. And we engineered 4 projects. They are exporting 80, 85 kilowatt hour per ton. But I started revisiting again with the fresh knowledge of technology. Because fresh knowledge of technology is always this waste heat recovery. That can you reduce the degree, minimum delta T, which is required for energy recovery. And on that basis, we have started working with another factory very close to this place, Goa, very close to Harry's place. It's near Belgaum. And 2 months back, we have given them a project that it will be 130 kilowatt hour per ton of cane. Now, 30 to 130, that's the quantum jump. Now, but for achieving all that, as I said, the loop is the technology, the policy, regulation, they have to come together. What my friend was saying, that there are sometimes incremental investment required. Sometimes you don't get the revenue the way, the revenue models have to be redesigned, the market has to be innovated. So during that process, unless we work together, we are not able to derive the best benefit. And these are the 3 experiences I wanted to share with you. Thank you very much.